Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to find the points of intersection using algebra. And I suppose the key phrase for us to understand today is what exactly are the points of intersection? And that is when two graphs overlap. And that phrase is going to be really, really important because our internal will have lots of concepts regarding intersections. So we can visually see, if we have a look at our graph, we can visually see that that point there is 4, 3, and that point there and that point there, that is 3, -4. But the trick is, we've been asked, and in our internal, we've expected to do this algebraically. So what this video is going to do, this video is going to set out with a couple examples of how do we find the points of intersections of these weirder graphs that we've been looking at, circles and hyperboles as well. So we're going to start off with this example. We already know the points, but let's try to get there algebraically. So the first step is normally to do with rearranging. And if you have a look at the formulas over here, what we need is we need one of the equations to be y equals or x equals. And sometimes this is easy, sometimes this is hard. But what I normally like to do is I normally like to focus on the y equals. So that means I can find the x coordinate first. And I'm actually going to focus on this first one because I can actually see y by itself already, which means I can just move the remainder to the other side. And I'm going to do that with my working on the left. So our equation, or our original equation, y is equal to, also y minus 7x plus 25, that is equal to 0. As I said, I'm going to move these parts to the other side. So that means y is equal to 7x minus 25. So that's our first step of rearranging. Step number 2, substituting. Now that we know what y is equal to, we're going to put that y into our second equation. So we are solving these equations through substitution. So let's write down our equation. Let's get into that. So x squared plus y squared is equal to 25. And as I said, we're going to substitute x minus 25 as y. So x squared plus 7x minus 25 all squared is equal to 25. So we've substituted that in. And the good thing about this equation, the only variable left is x. And we're going to try to find and solve for our x values. And that'll give us the x coordinate of the 2 points of intersection. So let's follow on with this algebra. So we're going to convert this to a double bracket. So that's going to be x squared plus 49x squared minus 175x minus another 175x plus 625. And that should be equal to 25. We're then going to look to clean all that up. So the x squareds, well, we've got 50x squareds. We've got negative 350x. And if we move that positive 25 to the other side, we're going to be left with 600. And all of that is equal to 0. And at this point here, you can flip that into your graphics calculator, and that'll give you the two solutions for x. But what I'm going to do is I'm just going to take out a 50 of each of these because I can see everything is a 50 involved. So that's going to be x squared minus 7x plus 12 is equal to 0. And you can also put that step into your graphics calculator as well. So your graphics calculator, hopefully it's going to tell you one solution to x is 3 and another solution to x is 4. And if you have a look at our coordinates, I'm just going to use the highlighter actually. There's x3 and there's x being equal to 4. So we found those two values. The final step, so step number 3, is find the coordinate. And that's basically saying find the y value because we've only got the x values at the moment. So let's start working with x1. So with x1, and what I am going to do is I'm going to use this formula y equals 7x minus 25 to find y, because that's my easiest equation to find y. So we could, in theory, use the other two equations from the top right, but we don't need to do that. Let's make our lives easier. So y is going to be equal to 7 times 3, and that's because our first value of x was 3, minus 25. That's 21 minus 25, which is equal to negative 4. And if you go back to our equation, so we said positive 3, and now we figured out that y value there. So that means, so therefore, one point of intersection, 3, negative 4. And we've been able to prove the bottom one algebraically. We now repeat the process for x2. So y is equal to 7 times 4, and that 4 comes from x2, which I've circled down the bottom, minus 25. And that's going to be equal to 28 minus 25, which is going to be equal to 3. And if you have a look at our other point above, I've now highlighted it. The y value was, in fact, 3. So we proved that algebraically as well. So therefore, our coordinate 4, 3, and that does match what we observed before. So we found 2 points of intersections for this intercepting circle and straight line. So if you haven't got this example down, including the steps, make sure you get it down with all the working. And what we're going to do is we're going to work on a second example with a hyperbole. But this time around, we're not going to have a graph to look. We're just going to get straight into the math. Okay, so we're back. We've got 2 graphs, including one hyperbole. Let's get into it. So first step is that rearranging step. So we need to figure out which way or which equation can we get y by itself. So we've got a y here, got a y here. The bottom one looks like a hyperbole, so that might be a bit more annoying to deal with. The top one does look like a linear line, so let's try to rearrange that one. So we've got 2y minus 4x minus 8 is equal to 0. So first step, let's move everything except for the y's to the other side. So that's going to be 2y is equal to 4x plus 8. We're then going to take that times 2 to the other side as division. So divide by 2. And we can then actually do that division. So 4x divided by 2 is 2x. 8 divided by 2, that comes to 4. So we've now got that rearranged, sorted out. We can now substitute that in as our second value of y in the hyperbole equation. So that's our second step, substitution. So let's put that in. So we got x plus 5, and we put in the y now, 2x plus 4. So that's where that came from. And that combined is equal to 8. We now go through our expanding process. So it's going to be 2x squared plus 4x plus 10x plus 20 is equal to 8. And we can then go through and finish off and simplify. So 2x squared plus 14x plus 12 is equal to 0. And at this point here, you can plug it straight into your graphics calculator, but I can see they've all got a common factor of 2, so I'm going to take that out first. So x squared plus 7x plus 6 is equal to 0. And the graphics calculator would reveal the first answer as -1, the second answer as -6. Now that you got those numbers, so the third and final step is find the coordinate, which really focuses on finding that y value. So we're going to use our easy equation from before to figure that out, because that's the easiest way to figure out y. So y, so if we're dealing with x1, y is equal to 2x plus 4, so it's going to be 2 times minus 1, and that minus 1 comes from our first value of x, plus 4. So that's going to be minus 2 plus 4, which is equal to 2. And that means our first coordinate is negative 1, comma 2. We can then carry on for the second x value. So y is going to be equal to 2 times negative 6. And that negative 6 comes from x2 down the bottom. We're then going to add 4 to that. So that's negative 12 plus 4, which comes to negative 8. And that means our final point would be negative 6, comma negative 8. So hopefully you found this video on finding the points of intersection using algebra useful. So we looked at hyperboles and circles with a straight line. Let's get into heaps and heaps of practice now.